Okay, you have a lot of examples from earlier videos. Remember, even the ones that I didn't work through are typed out examples of derivatives using the chain rule. But I still think we need to come back now that we verified what the chain rule says and go ahead and use it on a few examples. So the chain rule says that if you want to take the derivative of f of g of x, you need to find f prime, leave g alone, and then chain out, multiply by the derivative of g of x. So in this first function, a big part of this is just going to be identifying your f and your g. So the inner function here, I would say, is the 4x plus 1. And often there's more than one way to split this up, but remember the goal is to split up basically your shortcuts. So when I see everything raised to a power, I know I have a shortcut for that power. So I can pull that out as the outer function and leave everything else as the inner function. And that separates it into two pieces that I have the shortcuts to deal with. So first outer function is x to the 8th power. So its derivative is 8x to the 7th power. But we don't just have x, we have g of x. So we leave g of x alone in this first step. And then we chain out its derivative. We multiply by the derivative of 4x plus 1, which is just 4. We could certainly clean this up a little. I would multiply that 8 and 4 together and make it 32 times 4x plus 1 to the 7, but we don't have a ton of cleanup to do on that one. All right, next we have the square root of 5 minus 3x. So again, if I take this 5 minus 3x, this linear piece, and make that my g of x. The linear function is simple. I know how to take its derivative. That peels off just the square root as the outer function, and I do know how to take the derivative of square root of x. I do it by thinking of it as x to the 1/2 power. So starting with the outer function, x to the 1/2, derivative of that would be 1/2 x to the negative 1/2. But I have a g of x in there instead of an x, so I'll start by just writing the g of x down exactly as it originally appeared, and then I'm going to multiply by the derivative of g of x, which in this case is just -3. So I would regroup just a little bit. I'd make that -3 over 2 root 5 minus 3x, or you can leave that as 5 minus 3x to the 1/2, but you should try and deal with the negative exponent. Next, we have cosine of the cube root of x. So order of operations are you'd start with x, you take the cube root, then you take the cosine. So we don't really have a lot of options here. The two functions are cosine and cube root is the inner function. So that is our g of x. The derivative of our outer function, our f of x, is minus sine. Derivative of cosine is minus sine. In this first step, you leave that cube root of x alone. You don't do anything to it. But we do need to figure out its derivative for the next step. So x to the 1/3 prime is 1/3 x to the negative 2/3. Or 1 over 3 times the cube root of x squared, if you want to rewrite that in radical form. So that's what we're multiplying by, 1 over 3 times the cube root of x squared. And you could mush that into a single fraction, just move that sign of cube root of x into the numerator, but there's not a lot else you can do. That one's in pretty good shape, and I already rewrote without negative exponents. Okay, one more here, and that is 3 to the 2x squared minus x. So I see this nice quadratic function. I think I want to pull that out as one chunk, and that would be my inner function. If I plug x's in, I have to do all the steps up there before I raise 3 to the power, which means my f of x is just 3 to the x, 3 raised to a power. So the shortcut for f of x, the derivative of 3 to the x, is 3 to the x multiplied by the natural log of 3. I don't just have an x, I have a 2x squared minus x. So I'm not done. That natural log 3 is not the chain, it's just the shortcut for f. That's part of, this is all the f prime of g. I still need to multiply by g prime. The derivative of 2x squared minus x is 4x minus 1. Again, you could rearrange if you wanted to, but there's not a lot to do here that would simplify. You could distribute through to the 4x and the 1. I don't think it makes it look any better. If anything, it's maybe a little messier. So I think this one is fine just as it is. And one more time, I'm going to remind you that those first few intro pages that we worked through are tons of examples. So look back at those if you need to think about how the chain rule will apply when you have different kinds of functions in the mix.